Hello everyone, I am Precious, and in this video we'll quickly look at a review of a particular past question of the course Elementary Mathematics 1, that is Math 101 in the university where I teach. Okay, it's a year 1 course that covers the area of some of the topics we have been teaching in this particular channel. The topics such as types of numbers, set theory, indices, sorts, logarithms, permutation and combination, and binomial theorems, and many other topics. Okay, so I decided to also bring the instruction part. The exam is supposed to be for 1 hour 30 minutes, and then look at the instruction here, which says we should fill in these spaces with capital letters. So it's very important you take note of that. Then your signature and all of that. Now, the space you're seeing here is where you put in your answers. Now, the meaning of this is that this exam contained 33 questions and they are all objective. So you will solve, let's assume you solve number 1 and the answer is A. So you come here and shade your A. So it is your choice to determine what type of shading you want to do. You may also want to shade maybe by ticking, but it's always advisable to shade this way. Okay, so now before we go right into it, it's important we see this instruction here. It says that the symbols N, Z, Q, Q prime, R, and C denote the following respectively. N for natural numbers, Z for integers, Q for rational numbers, Q prime for irrational numbers, R for real numbers, and then C for complex numbers. Okay, so quickly we will go right into it. Of course, you should always remember that exams is all about speed and accuracy. Okay, so we begin with the beginning part of the exam, which is the number 1. The number 1 here is from logarithm, and it says that we should evaluate log x base 9 equal to minus half. So what do? We'll simply solve this following the definition of logarithm. And that definition says that if I raise the base of a logarithm to the value of the logarithm, that it is equal to the number. This is the number, this is the base, and this is the value. So that means my x is equal to 9 raised to the power of minus half. And of course, this is the same thing as by indices. This is going to give me 1 all over 9 raised to the power of half, which is equal to 1 all over, of course, power half means square root of 9, and that is equal to 1 all over 3. And you can see here now that our solution for number 1 is B. Okay, so quickly we go to example 2. Number 2 says that we should simplify this. So I'm going to quickly start the simplification. You recall that when everything in bracket is raised to this power, that means this power is going to multiply all the powers of each of the terms inside the bracket. So if 2 over 5 multiplies 5, of course, what will happen is that 5 will cancel 5. So you only have 2 left. So the x there is going to be power 2. And then the y is going to be, the 5 here will cancel the 5. And so you have minus 2 left. And then you have z. The z power is minus 3 multiplied by this. That will give you minus 6 all over 5. Okay, then this is times. Now remember that root means power of a fraction. That means this is the same thing as x raised to the power of 5 multiplied by y raised to the power of 2, z raised to the power of 18 all over 5. And then now cube root here means 1 all raised to the power of 1 over 3. And this is divided by, we can also open this bracket, and when we do that, we will have x to the power of 5 all over 3. That's 1 over 3 multiplying 5. And then we now have 5 raised to the power of 2 over 3. Sorry, y raised to the power of 2 over 3. And this is going to give us, of course, this is the same thing. So we'll just simplify this a little bit. So we are going to have x to the power of 2, y to the power of minus 2, z to the power of minus 6 over 5. And this is multiplied by, if this now comes into the bracket, you will have x raised to the power of 5 over 3 times 2 raised to the power of 2 over 3. times z raised to the power of, if this 1 over 3 multiplies this 3 will cancel this 18. And so you will have 6 over 5 left there. And this is divided by x raised to the power of 5 over 3 multiplied by 2 over 3. Okay, so I am going to apply the law of indices here now, which says that multiplication of the same base is the same thing as summation of the powers, and then division is subtraction. So I'm going to pick x now, and then the powers of x I'm going to add for multiplication and then subtract for division. So I'm going to have 2 plus the power here is 5 over 3, and then the power here is also 5 over 3, but in this case it will be subtraction since what I have there is division, and that will be times y to the power of the power in the first bracket is minus 2 plus the power in the second bracket is 2 over 3 minus the power in the third bracket is 2 over 3, and then I have finally z to the power of, in the first bracket, it is equal to minus 6 over 5, and that is plus, in the second bracket, is positive 6 over 5. And so this is going to now give us that, of course, this will take away this, and this will take away this. So you just have x squared y raised to the power of minus 2. This will also take away this. So you just have z raised to the power of 0, which is actually equal to 1. So this is our solution, which we can also write as x squared all over y squared. By indices, this will become 1 all over y squared. And we can quickly write this as x all over y all squared. And of course, if you check in the option, there is no option there. This is what wanted to look like it. But please note, it is wrong to choose nota. Nota means, it's wrong to choose a solution that is close to what you are supposed to have. So when it is not in the option, please always take your E, which is nota. That is none of the above. Okay, so we go to the next one. Here, example 3, we have, question 3, we have that we should put this in this form and then evaluate this. And so to do that, I am going to rationalize the surd. This is from surd. So I have 3 root 2 minus 4 root 3. So I'm going to multiply by the conjugate of the denominator, which is just to change this to plus. And this will give me plus root 3 all over 3 root 2 plus 4 root 3. Okay, so when you do this multiplication, you are going to have, of course, this will multiply these two, and this will do the same. So 5 root 2 times 3 root 2 will give us 15 times 2. 5 root 2 times this will give us 20 root 6. And we are done with that. So we go to this other one. 2 root 3 times 3 root 2 will give us 6 root 6. And then this times this will now give us 8 times 3. Excuse me. Yeah, na-emezila ụzọ. Hello? Na-emezila ụzọ there. Na-emezila mkpọtụ biko. So this is all over. Of course, recall how to do this. The denominator, since they are conjugate, just use this and multiply this. And that's going to give us 9 times 2. And then minus, then just use this and multiply this, which is 16 multiplied by 3. And of course, this is going to give us, this is 30 plus 18, which is 48. And then this is 20 plus 6, which is 26 root 6. All over, this is 18 minus 48. And that's going to give us minus 30. So of course, if you split this, we are going to have minus 40 all over 30. And that is minus 26 over 30 root 6. And so they asked us, we have put it in this form. So this is our A. The whole of this is our A. And then our our B is what is under the root, which is 6. And they're asking us to find 5a plus b, meaning we should multiply our a by 5, which is minus 40 over 30, and then we should add b to it, and our b is 6. So if this multiplies this, of course, this will cancel to give you 5. Sorry, this is 48. This is 48. Okay, and of course, if this cancels this, we are going to have 6 here. So, and this place is 48. 6 will divide 48 to give us minus 8 plus 6. And this is equal to negative 3, which is option A. So for number 4 here, what are we? The same definition. So we have log y base 10 to be equal to negative 2. This means that y alone is equal to 10 raised to the power of minus 2. And then they ask us to evaluate this. Just substitute into that. So I'm going to substitute my y now. And so I have square root of 10 raised to the power minus 2 base 10. And of course, square root is the same thing as power half. So I'll have this times half. So this will take away this, and this is base 10. So this will give me log 10 raised to the power minus 1 base 10. Of course, this one will come to the back to give, minus 1 to give me minus 1 log 10 base 10, which is equal to 1. And then 1 times minus 1 is equal to minus 1. And so your D is the correct option for number 4. So number 5 here asks us to quickly evaluate this. And so what do you do? Now, of course, we know that root of 81 is 9 plus, and root of 16 is 4 minus root of 625 is also a perfect square root and is 25. And this is divided by, remember that here we have the 216 can actually become 216 all over 125 because subtraction in logarithm changes to division. So this is now going to give us, we will do the same thing up here. 9 times 4 because addition changes to multiplication. So we'll have 36 all over 25 here. And then everything is all over this 216 over 125. And now what do I do from here? I can see that I can actually, all of these are perfect squares, while these are perfect cubes. So this can actually give me log 6 squared all over, let me do it this way, log 6 over 5 all squared. Of course, if you open this bracket, you will get back your 36 over 25. And we can do the same thing here, 6 over 5 all cubed, because the cube of 6 is 216, while the cube of 5 is 125. So by logarithm law, bring the 2 to the back, bring the 3 to the back, so you have 2 log 6 over 5 all over 3 log 6 over 5. So here you have the same value, so I can quickly take away this logarithm, and so my answer is 2 all over 3, and that is option C. And so we quickly go to number 6 here. Number 6 says that we should evaluate this. So the first thing to do is to open this bracket. If you do that, you have 7 over root 2 will multiply each of the terms in the bracket. So we'll have 7 root 32 all over root 2, and that is plus 7 times 8 here will give us 56 all over root 2 times root 2 is 2. So of course, by rule of Surds, you know that root A all over root B is the same thing as root A over B. So I'm going to open a bracket now, one root, and I'm going to have 32 over 2, and that is plus 56 over 2 is 28. So remember, this is multiplication, not a seventh root. So I have this, and then 32 over this is 16. So, and root 16 is actually 4 times 7 is 28 plus 28, which will give me 56. So remember what I said, you just have to be as fast as possible. So we go to the next one. Number 7 says, this is from binomial theorem. It says that we should find the constant term in this expansion. So that means you should expand this. And you remember how we do expansion? We either use combination approach or the Pascal's triangle. And if we use the Pascal's triangle, it helps us to get the coefficients. So of course it starts for the power 6. The coefficients are going to be 5, 6, because of our time. No need showing all of that. 5, 6, 15, sorry. And then we have 20, then 15 again. And then you have 6 again, and then you have 1. And so for each of these coefficients, you are now going to be multiplying each of the term. If you multiply the first term, if you bring the first term, you raise it to the highest power, multiply by the second term, raised to the least power, which is 0. And then you keep reducing by 1 and increasing the second one by 1. So that means the first one here is going to be x raised to the power 6 multiplied by 1 all over x raised to the power of 0, which is actually 1. Then you will add. Remember that the coefficient is 1, which is this. Then the next one will be 6 times x raised to the power of 5, then multiply by 1 over x raised to the power of 1. Now, there is no need to do all of this because they just asked us for the constant term, meaning where there will be no x at all. And remember that in this expansion, you are expected to ensure that the sum of the powers you have here must be 6. This is 6 plus 0, which is 6. 5 plus the power here is 1, which is also 6. The next one will be 4 plus 2. So which of the two sums that will give us 6 is able to give us something that can cancel the x? And that is the 1 for here. And what is it going to be? Remember, this one is for this. So the next one will be 4, 2. And so the next one is going to be 20 multiply x will be power 3 multiplied by 1 all over x to the power of 3 also. So the sum of this will give you 6. So the rest is not going to give you something that will cancel. And how do I mean? If I expand this by indices, I'm going to have s cubed times 1 cube is 1, all over s cube is also s cube. So what happens here is that s cube will cancel s cube. So it is only on the expansion here that will happen. If you get here, it will become 2, 4. This will become 1, 5. This will become 0, 6. So there is no how it can cancel any other place except at this point. And so that means if I now expand this, finally I have 20. Therefore, the coefficient is actually 20, which is B. Then we go to number 8 here. Number 8 is actually from types of numbers joined with set theory. And so we know this as natural numbers, integers, and then we have this as irrational numbers. So what is of course, we take the bracket first. So we have the natural numbers union. What is the intersection of Z and Q? Remember, Z is contained inside Q. That's irrational numbers. But Q and Q prime are completely empty. And so what that means is that anything that is contained under Z cannot be inside Q prime. And so their intersection would definitely be an empty set. Okay, so when you now take the union of N and the empty set, you will get N. Remember that how to handle this is that if a set is greater than another and is containing it, then their union will be the greater set. But if a set is smaller than the other and is inside, for example, if A is inside B, then if I take A intersection B, I am going to get the smaller set, which is A. If I take the union, I am going to get the bigger set, which is B. All right, and that's how we got our N here, which is option A. So we go to the next number, which is 9. So the same thing we are going to apply here for number 9. Here, A is contained in B. So what is this intersection? Remember that B backslash A means B without A. That means the set of elements in B that are not in A, meaning that the elements of A will not be here at all. So when you take the intersection of A and something that does not contain A at all, the intersection is definitely going to be the empty set because they don't have anything in common, because all elements here are only found in B, they are not found in A. And so we go to number 10 quickly. So here, what do? We divide both sides by 3. If you divide here by 3, you get 8, so that you can clear this 3 here. And then you divide that side, you get 2 raised to power x. So by indices, I'll take two of them to the same base, and then therefore my x becomes equal to what? 3. And so they say we should find x squared, which is 3 squared, and that is 9. And then number 11 says the following are irrational numbers except. So this is an irrational number. This is an irrational number. Now the square root of 9 is 3, and 3 is not an irrational number. So C is the correct answer here. Number 12. The question says that cos theta is equal to half. What does that mean? If cos theta is equal to half, it means that theta is cos inverse of half, and cos inverse of half is 60 degrees. And so they say we should find the value of cot. But we know that cot is 1 all over tangent. So let's quickly get our tangent. What is the value of tan 60? Tan 60 is actually root 3. And so that means that cot 60, which is the theta, is then going to be 1 all over the root of 3. And that's our solution, which is A. So we go to number 13. 13 says that we should solve this. And what are you going to do? First of all, see here that we can actually remove this. The square can remove the square root. And so here we just have only the square of this plus 3 plus 1 equal to 3x. So I can take this to the other side. So I will just have the square root of x plus 3 equal to 3x minus 1. Now let the square root go to this side, then it becomes a square. And so I'll just take the square of both sides. So if I take the square of both sides, I am going to have, this will go, so I'll just have x plus 3, and that's equal to the square of this side. Let me quickly put it this way. So the square of this is going to be 9x squared minus 6x plus 1. So collect like terms, let everything here go this way. So I'll have 9x squared, x coming here will become minus x, and that will give me minus 7x. 3 coming here will become minus 3. 1 minus 3 is minus 2. Everything is equal to 0. And to solve this, if you go to my previous video, just the video before this, you are going to see that to solve, under how to factorize. So I can actually factorize this. If you multiply 9 and minus 2, you have minus 18. So what are the two factors of minus 18 that will sum to minus 7? And that is minus 9 and positive 2. So I will just come here, open my bracket, put minus 9, open another one, put positive 2, and that's equal to 0. But the coefficient here is not 1, so we pick that coefficient, use it to divide this number, use it to divide this. So this will go away. You have x minus 1 is 0, or x is equal to minus 2 over 9. So if you solve this side, you have x is positive 1, and there is positive 1 here, and that is our solution. So for the next one, number 14 here, we have that if this is equal to this, and what's the meaning of this? This thing actually means combination. This is another way to write combination. That's 18 combination R. Okay, so this is 18 combination R. But however, that's not where I am interested in going. But we can use that. So that means the other one is 18 combination R plus 2. Now, there is a law which we call the complement rule under combination and permutation, especially combination, which says that if NCR is equal to NC, let's say R plus 1. Let me use this as an example. What it means is that N is equal to the sum of these two, which is, I should have just used another letter here, maybe K. So it means that N is equal to R plus K. So if you have 10 combination 3 is equal to 10 combination 7, the sum below must be equal to your N. So if we use that rule here, what it means is that our R, if we sum these two, R plus 2, it must be equal to the N, which is 18. And then solving from there, this is going to give us 2R is equal to 18 minus 2, which is 16. Therefore, our R is 8. Now, but the question says we should find R plus 1, which is equal to 9. And that's option B. Now, this one says, which one of the following is not a rational number? And of course, this multiply this is going to give you 3, is a rational number. This is already a rational number. That's a fraction of integers. Now, this is definitely not a rational number. Now, of course, this is going to cancel the square root. You also have 3. So this is also rational. So the answer is C. Finally, for this, we have the number 16, which says that 2 raised to the power of x is equal to root of 64. And root of 64 is equal to 8. So that means if I take this by indices, I'll have 2 raised to the power of 3. If I remove the equal basis, x is equal to 3. And then they said this other equation holds. What that means is that since my x is 3, I can have 3 over y is equal to 3 over 1. Cross multiply, you will have that 3y is equal to 3. Therefore, y is equal to 3 over 3, which is 1. So then to evaluate this, just substitute your x and your y. So if I put my x as 3, then 3 raised to the power 3 plus 9 times 1. And that's going to give me 27 plus 9, which is equal to 36. And that is the solution. So of course, you can see the answer is not here. So the none of the above becomes our solution. So for number 17 now, we are asked to determine what set B is going to be if these definitions hold. And what was the first thing? That the elements of set B must be from set H, and such that this happens. So for that to be what, and meanwhile, what is our set H? This is our set H. So B is such that X is in H. So all of this H, such that any X you pick must be, when you multiply by 7, must be greater than 50. So all we need to do is to solve this inequality. And we divide both sides by 7. If you divide both sides by 7, we'll have that our x must be greater than 7 over 50 over 7, which is 7 whole number 1 over 7. So something greater than 7, 8, 9, and all of that. Okay, so we come back to h to check. Meanwhile, what is our h? Our h is actually a set of odd numbers. We have 1, 3, 5, then 7, and 9. So among all of these, the only one that satisfies this condition is what? 9. Therefore, our set B is a singleton set containing only 9. So C is the correct answer here. So we go to number 18. Here, now remember that number 17 is from set theory. Now from 18 is from sequences and series, particularly arithmetic progression. So we are given an expression for the nth term, and they said is equal to 5 minus n over 2. So the meaning is that whatever t you want to find, just substitute your n. And so now they ask us to find t1, that's the first term and the common difference. Now T1 here means that anywhere I see n, I should call it 1. And that's going to give me 5 minus 1 all over 2. And when you subtract this, you have 4 over 5, which is actually the same thing as 9 over 2. So what about the common difference? Remember that there's a formula that says that common difference, says that common difference D is equal to Tn minus Tn minus 1. What this means is that if I want to find the common difference of an arithmetic progression, all I need to do is to get a term and subtract the previous term. So in this case, for me to get this, I will need at least the T2. So let's get our T2. So our T2 is going to be 5 minus, our n now will be 2 all over 2. And this is going to give us 4. Of course, 2 over 2 is 1. So that now means that our common difference is going to be equal to our D, that is equal to T2 minus T1. And what is our T2? 4. And our T1 is 4.5. So if you subtract this, you have minus half left. Therefore, what they're asking us to get is 9 over 2 and minus half, which is actually option B. So we move over to the next one, number 19, which is from partial fractions. And they are only asking us to get this, and to evaluate this, we will need A, B, and C. So all we need to do is to split this into its partial fraction, get the values of A, B, and C, and then put it here. So let's start doing that. And so that's going to give us 3x squared, that's for 19. 3x squared all over x plus 2 all cubed is equal to, so I'm going to quickly take the LCM of the right hand side. The LCM is x plus 2 raised to the power of 3, and so I'll use this to divide, and then when it divides, what am I going to get? I will have x plus 2 squared left, so you use it to multiply a. So I will have 8 times this squared. Then plus, I will go to b, use the denominator to divide, and then I will get only x plus 2. Use it to multiply b, and that will give me this. Then plus, I will go to my c, use this to divide, which will give me 1. 1 times c is c. And so by normal partial fraction, the denominators will cancel, and then I will get that the numerators are equivalent. Sorry, this is plus 5. So what it means is that 3x squared plus 5 is equivalent to the numerator of the right hand side, which is a into x squared x plus 2 all squared plus b into x plus 2 then plus c. So to be able to solve for my c, there are two methods I can use here, or ABC, sorry. I can actually expand and compare both sides, or I can use the first. At least there is something I can do to get my c very fast, and that is to eliminate a and b. And if I want to eliminate a and b, I will make x minus 2, because if you put it here, you get 0. If you put it here, you get 0. So let's do that. Substitute to the left hand side. X minus 2 squared will give us 4. 4 times 3 is 12. 12 plus 5 is 17. And that's equal to, now if I put x minus 2 here, 0, 0, and then I just have that my c is that my c is 17. And so just a quick check, if you put 17 here, that means this guy is not going to be part of it. So I have 17, 17. So I would have to get from A, B, C. So let's go now. So at this point, there is nothing else we can substitute. So, okay, so one of the things we can also do here is just to expand now and then substitute C. So if we expand this now, we're going to have 3x squared plus 5 is equivalent to, and so I'm going to have a into the bracket. If you expand x plus 2 squared, you will have x squared plus 4x plus 4, and that is for the first one. Then you now have bx, that's opening the bracket, plus 2b plus c, which you have gotten now to be 17. And so open this other side also, or let's leave that our c as what it is. Let's leave it as c. And so what we now have here now is going to be that this is equivalent to, open this bracket, we'll have ax squared, then we'll now have 4ax, then we'll have 4a, and that is plus our bx, then plus 2b, then plus c. Okay, so if you compare both sides now, the only coefficient of x squared on the right hand side is a, and on the left hand side is 3. Therefore our a is equal to 3. So we have gotten a. We are now left with b. So for b, we can make use of either the constant or the coefficient of x. The coefficient of x on the right hand side is equal to, look at it, join these two. So you are going to have 4a plus b all into x. So the coefficient of b is 4a plus b. So 4a plus b must be equal to the coefficient of x on the left hand side, and there's no x here. What it means is that the coefficient is what? 0. And we already have our a as 3. That means 3 times 4 is 12 plus b is equal to 0. So the implication is that our b is negative 12. Okay, so now put everything here now. So it means that our a, let me use this, our a is 3, our b is, sorry, the next thing is 2 times b, which is minus 24, and then you now have 17. So let's come here to check which one satisfies that, and that is our option A. Okay, and then what about the next one? Here they said we should calculate the arithmetic mean of this. Arithmetic mean is simply equal to the sum of the two divided by 2. So you have minus 10 plus 22 all over 2. So you sum and divide by their number. And this is going to give us 12 all over 2, which is equal to 6. And that is option B. And so we go to, this is just a knowledge question asking you to state which one is not true. And let's read. A set whose cardinality is 0 is called an infinite set. This is, of course, not true. And that is your answer. Because if the cardinality of a set is 0, it means it's not set. So you can actually determine the cardinality. It's part of the definition. An infinite set is a set that you cannot determine the number of elements. So that means this is not true. You can check the next one. Two sets are said to be equal if they contain exactly the same elements. That is true. Two sets can be equivalent without being equal. That is true. You can have two sets that have the same number of elements. That's equivalence. And yet not equal. Yes. So every set is a subset of itself. That's also true. So only A is the option that is not true for number 21. Okay. And okay, so we quickly go to the next one, which is number 22. And here it says solution. So for 22, we are asked to form a quadratic equation for which of the sum of the roots is 6. So let the roots be alpha and beta. So the sum is equal to 6. And then the sum of their squares, that's alpha squared, the squares of the roots, plus beta squared is equal to 58. Okay, now remember that we are told that every quadratic equation is of this form: x squared minus alpha plus beta, that's the two roots, assuming the roots are alpha and beta, times x, then plus alpha beta, and that is equal to 0. There's a general formula for quadratic equations that is of this form. So all we need to do now, we already have this, that's the coefficient of bx, and so we need to get alpha beta. Now, but recall that we have that our alpha squared plus beta squared by symmetric properties of roots is actually equal to alpha plus beta all squared minus 2 alpha beta. Yes. And so all you need to do now is to substitute our values. So I was given that alpha squared plus beta squared is 58, and so that's equal to alpha plus beta is 6 squared minus 2 alpha beta. And so this is so take this to this side and bring this to this side. So if this one comes here, it becomes positive 2 alpha beta, and that is equal to 6 squared is 36. 58 coming here will become minus 58. And so that is going to give me that my alpha beta is equal to this minus this is going to be equal to negative 22. And so when you divide by 2, you have minus 11. Therefore, the equation we are looking for is simply x squared minus the whole of this is 6, which is given here, and then attach your x, then the whole of this, which is alpha beta, is minus 11 from what we have here, and everything is equal to 0. And so that is what we have as option B, and that's the solution. So we go to the next one, number 23, which is also from polynomials, and particularly from factor theorem. And it says, for what value of p will this particular polynomial be divisible by x minus p. For this, just equate this to 0 and get your x. Therefore, our x is equal to p. So substitute this x into this, and by factor theorem, if you do this substitution, your value must be equal to 0. And so when we get 0, we then solve for our p. So let's do that. So I'm going to put, anywhere I see x, I'll put it as p. So I'll have p cubed minus p plus 6. Then x now is also p plus p squared into 6p plus c. My x there is p, then minus d, all equal to 0 by factor theorem. So what this means is that I am going to have, just expand all the brackets, then p times this is going to give me p cubed. Then I'm opening from the right first. Then 6 times p squared is also p squared. Then I can open this one straight ahead. So I have 6p squared plus pc. I did this because there is minus here, so you open from the right and from the left. But in this case, it's just positive. Just go ahead and open. So, and this is equal to 0. So finally, I can now open so that the negative sign will multiply everything. So I'll have p cubed minus p cubed. Then minus times this is also minus 6p squared, and that is plus 6p squared, and that is plus pc minus d equal to 0. Okay, so finally you can see that this will take away this will take away this. So we only have pc minus d to be equal to 0. Take that to the other side, so pc is equal to d. So divide both sides by c to get your p. That's what they asked you for. Therefore, our p is equal to d all over c. Of course, this will take away this. And that is somewhere here, option B. So we go to the next one, number 24, which is asking us, 24 says that we should that the roots of a quadratic function of the form this are real and repeated if graphically the curve cuts. Okay, so you recall that we have also seen this even on this channel. You can also watch, that is under types of roots or forms of roots. I've explained that. So this is our y-axis, this is our x-axis. For you to have real and repeated roots, real roots means that it will touch the x-axis. Repeated means it will touch it just at a point, something like this. Okay, so just at one point. So this is the solution A. Now the second one, that's number 25 here, says that we should find, so this is option A. So I'll go to number 25, which says that we should find a remainder when this polynomial is divided by this. This one now we also use remainder theorem, which says that if I equate this to 0, that's the divisor, and solve for x, that if I substitute this value of x into the polynomial, whatever I get is the remainder. So the remainder I'm looking for is equal to 3 raised to the power of 3 minus 7 into 3 squared plus 11 times 3 then plus 6. And that's going to give me, this is 27. The 3 squared is 9 times 7. 9 times 7 is also equal to 63. Then this is going to give us 33 and then plus 6. So if we subtract this, if we add everything here, this is going to give us minus 30 plus this is minus 3 plus 6 is equal to 3. And there is no option like that, and so this is option E, that's none of the above. Okay, so finally for this page we go for number 26, and number 26 says that we should find the sum to infinity. This is coming from geometric progression. Sum to infinity written this way is actually equal to A, which is the first term, all over 1 minus r if your r is less than 1. And of course we can see it here. How do we get our r? Our r is always equal to a term divided by the previous term. So we can use 1 over 16 divided by 1 over 8. And of course I can have this as 1 over 16 times 8 over 1, which will give me 1 over 2 if this cancels this. Okay, so we put that here. We are going to have a, which is 1 over 8, all over 1 minus 1 over 2. And that is going to give us 1 over 8 divided by 1 over 2. And this is equal to 1 over 8. If you change division to multiplication, you have 2 over 1. And this will give us 1 over 4 as the solution. And here again, we can see that the solution is also not there. And so we also choose none of the above as our solution. So to the number 27, they ask us to simplify this. This is from factorials. And of course, you can find factorial, the video to factorial in our channel here. So this is going to be, we have x squared plus 2 factorial all over x squared minus 1 factorial x squared plus 2. So what are we going to do? Now look at the denominator. The denominator has x squared minus 1. So remember the formula for factorial. If you have this is the same thing as n times, you keep subtracting 1, you keep subtracting 1, just like that. So if I subtract, if I just bring it the way it is, I am going to have my x squared plus 2 times, I will remove 1, that's x squared plus 1. I will remove 1 again, that's x squared. I will remove 1 again, that's x squared minus 1. Why am I going that way? I want to get to what is in the denominator, so I can stop here. Then this is all over, and then in my denominator, I just write what I have there, and then here I also bring it down. Now at this point, you can see this x squared minus 1 factorial will remove this, and already you can see x squared plus 2 there. So this is going to give us, if this multiplies, you have x raised to the power 4 plus x squared as our solution. And that is option D. Now this one says, how many numbers greater than 3,000 can be formed using the digits we have here? This number 28 is from permutation and combination. Very important question there. Now look at what we have. We have 5 digits to form a 4-digit number. So there are 2 ways we can form this. Remember, they say without repetition. So the first way is that we can use any of the numbers. That's to form a 5-digit. Any 5-digit number you form will definitely be greater than 3,000. So that means form any 5-digit number. And if we form any 5-digit number from here, that means we can pick anyone, and that's actually equal to 5 factorial. Okay, and then the next way, let me bring this thing I'm doing down here. So the next way we can get a number that is greater than 3,000 is to now form 4-digit number, but the 4-digit number we are going to form must begin with must begin with a number that is greater or equal to 3. So from here now, we can pick 3, 4, or 5. So what it means is that, look at what is going to be. We're going to have the 1,000 column, then we'll have the 100 column, then we have the tens column, and we have the unit column. So we're going to be using counting system here. So for the 100 column, only numbers 3, 4, and 5 can be here. So only 3 can enter here, and that is times. Now what about 100 column? How many can enter? Now all of them can actually enter here, and it will be greater than 3,000. However, they said without repetition. So meaning if I pick any of 3, 4, and 5, I will be left with only 4 digits to pick. So only 4 can enter here, times. Now also, if I've picked any of 3, 4, and 5, and I've picked also for 100 column, then for tens column, only 3 digits will be left to be picked. And in the same vein, only 2 will be left here to be picked. And so if we multiply this, we are going to get the next the next number of digits that can help us get, the next number of formations that will give us number greater than 3000. And this is going to be 12, 24. 24 times 2 is 48. And so now, whereas this one is 5 factorial, which is 5 times 4 times 3 times 2 times 1, this is 20, this is 60, 120. So the total number of digits that can be formed from these numbers without repetition that will give us a number greater than 3000 is 120 plus 48, and that is 168. And of course, you can see it is not in the option, and so that is what? Sorry, please look at the mistake here. This is not 48. It's a mistake. I'm sorry about that. Okay, look at it. This times this is 12. 12 times 3 is 36, not 24. And 36 times 2 is 72. So sorry, we're supposed to have plus 72 here. And when you add 72 to 120, we are then going to have 192, and it is still none of the above. Okay, so so quickly we then go to the number 30. Now look at this one. It says that we should use the information below to answer the following three questions. That's from 30 to 31 and 32. Remember, I said that there are 33 questions. So let's look at this. It says that you are given a universal set, which is this, and then that's minus 10 up to 100. And then they're asking us this, and A is this from 30 to 40, from B is 25 to 60, and C is 40 down to 29. Okay, so we can actually list these elements if we want. Now, but they say we should determine A complements, meaning elements in the universal set that are not in A. So what is that going to be? Let's try to, where we can actually list, like I said, but there will be no point. So look at it. So our A complement is simply going to be, so A started from 30. That means minus 10 is not going to be there. So I'll go from minus 10, minus 9, down to, remember these elements are just whole numbers, so there's no point, down to 29. So 29 is not here. And then I will now jump up to 40 is in A. So I will begin from 41, 42 down to 100, which are elements in the universal set. This is the complement of A. Let's look at the options, and it is somewhere here, option C. That's the solution for number 30. And then we'll quickly go to the next one, which is 31. 31 says B intersection C intersection A. So we'll keep referring back to this place. What is our B? This is B. They said intersection C intersection A. Okay, so 31 is B intersection C intersection A, meaning elements here, here, and here. Elements in these three. Okay, so what are the elements in the three of them? Okay, let's begin. From here, of course, 25 to 40 contains, to 60 contains 40 in between. So 40 must be in that intersection. Then what else? Okay, now remember that this one now is going down this way. This one is going down. This one is going up. Okay, so the other thing that will be in this will definitely be 39. 39 will be there because 39 is here, is also here. Then 38 will also be there, and 37 will be there. And in fact, you keep going down, and the only thing is that for this one now, you are going to stop at 30 because 30 is also here and 30 is here. Remember, this one moved down, so it crossed 30 before getting to 29. We can't pick 29, even though 29 is here, but it is not here. So we are going to stop at 30, and let's check. Okay, so from 40 down to 30, that is definitely option A. And then back, they said we should find n of A plus n of B. What's n of A? Cardinality of A, number of elements in A, and n of B is cardinality of B. So let's go back. So can we check the cardinality from 30 to 40? Of course, from 31 to 40 is 10. That's 10 elements, 10 numbers. Then if you add 30, so it means that for number 32, the cardinality of A is equal to 11. And then the other one is cardinality of B. Let's look at it. From 31 to 60 is going to be 30 in number. That's if you number from 31 to 60, you have 30 numbers. Then what about from 25 to 30? Sorry, if you number from 31 to 60, will be 30 numbers. Then what about from 25 to 30? You can count 25, 26, 27, 28, 29, 30. These are 6 digits, so you add it here. So you have that your n of B is equal to 36. Therefore, the sum of the two will give you 47 as your solution. And you can see that here as option C. And then finally, we have that we should solve this inequality. So for number 33, to solve the inequality here, I have minus 5 is less than 4x plus 15. All I will need to do is collect like terms. So take this 15 to this side. So I'll have minus 5 minus 15 is less than 4x. If I join these two, I'll have minus 20 is less than 4x. Divide both sides by 4 to make x the subject. So this will take away this. And if I divide this side, I will have minus 5 is less than my x. Please don't be deceived with the mistake of thinking because there's negative sign here, you can change the sign. No, because you only change the sign when you divide by a negative number. And here we divided by a positive 4, so you don't need to change the sign. However, I can actually turn this the other way around. And so instead of writing minus 5 is less than x, so I can write it as x is greater than minus 5. And they are just the same thing. And that is our option C. And that quickly brings us to the end of the review of this particular past question, which I said is for, I think, 2020-2021 academic section. And I also showed you how to shade your questions. Once you answer, you go to that upper page and shade accordingly. Okay, that's somewhere here. You shade accordingly. And remember, like I said, it is speed and accuracy that determines how fast you can go and how well your results can be. Okay, so kindly subscribe to our YouTube channel. You can always reach out to us if you have any question further for us. Okay, these are the things we saw. Right, peace out.